Friends, welcome to my YouTube channel. Tanesh here. Today we are going to discuss about feature engineering, and I believe this is the fourth video on feature engineering. In this video, I am going to discuss how we can handle outliers. That's what we are going to discuss in this video. Let's start. Just I am giving an introduction like what are all the steps we usually follow when we address a machine learning problem. These are all the steps we follow when we address a machine learning problem. One is gathering data, second one is cleaning data, the third step is the feature engineering, defining the model, then training, testing the model, and predicting the output. These are all the steps we follow when we address a machine learning problem. See, the goal of feature engineering is preparing the proper input data set, improving the performance of machine learning model. These are all the goal of the feature engineering. Now, next we are going to discuss what is not feature engineering. See, we need to understand data collection is not feature engineering and data pre-processing is not feature engineering. Creating the tag labels when labeling the data is not feature engineering. Scaling or normalization is not feature engineering. The PCA, principal component analysis, is not feature engineering. And the last step in the machine learning, which we call the hyperparameter tuning and optimization, is not feature engineering. Then what is feature engineering? In feature engineering, we convert data into features. That's what we do in feature engineering. See, these are all the list of techniques we use in feature engineering. The first one is imputation, handling the missing data. We already covered this. We prepared a video you can watch in the playlist. Feature engineering, imputation, it's already done. This part, it is done. Imputation, it's done. Then next is handling outliers. In this video, we are going to discuss about handling outliers, then binding, lock transform, one-hot encoding, grouping operations, feature split, scaling, extracting date. These are all the steps we follow in feature engineering. We are going to discuss all these steps in detail. So in this video, we are going to focus on how we can handle outliers. That's what we are going to discuss in this video. So let me talk about what's an outlier. In statistics, an outlier is an observation point that is distant from other observations. For example, you have some points like I have some points like 21, then 22, then 25, then 26, then 29. Then another value we have here is 5. Then here 5 is an outlier because all other numbers are very close: 21, 22, 25, 26, 29. Everything is very close. Here 5 is an outlier. So that's what you need to understand. So these extreme values can be present in both dependent and independent variables. In the case of supervised machine learning, you know, the dependent variables and independent variables, you know. See, when we talk about the equation y is equal to mx plus c, y is the dependent variable and x is the independent variable. Y, we call it as the target variable. So the dependent variable, we also call it as the target variable, you know it. So these extreme values can be present in both dependent and independent variables in the case of supervised machine learning models. These extreme values need not necessarily impact the model performance or accuracy, but when they do, they are called influential points. When these extreme values, impact the model performance or accuracy, we call them as influential points. One more point you need to understand here is the extreme values in independent variables are points of high leverage. So we call it as the points of high leverage. If these extreme values are present in independent variables, we call it as the points of high leverage. If these extreme values are present in dependent variables or target variables, they are known as outliers. These extreme values can be there in the dependent variables and independent variables. If these extreme values are present in independent variables, they are the points of high leverage. And if these extreme values are present in the dependent variables, they are known as outliers. See, for outlier detection, there are different steps we can use. These are all the methods we usually use for outlier detection. One is the box plot, that's a visualization tool. Scatter plot, it's also a visualization tool. Z score, mathematical, it's a mathematical function. IQR score, it's also a mathematical function. Cook's distance, k-means clustering, it's a algorithm, extreme value analysis. Sorry, these are all the steps you follow. Sorry, for outlier detection. See, the visualization steps we use are the box plot, scatter plot, then Z score and IQR score are mathematical functions, Cook's distance, k-means clustering algorithm, extreme value analysis. See, these are all the steps methods we use for outlier detection. Now, it's for outlier treatment. We have these methods. One is the mean, median, or random imputation, trimming, top, bottom, and zero coding, discretization. See, these are all the steps we follow for the outlier treatment. See, in this video, I am just telling these methods. In the next video, we are going to discuss in detail how we are going to perform the outlier detection and the outlier treatment in detail. So that's all for today, for how we can handling outliers. This is just an introduction for that. Each method will be, how we can do it, that will be discussing in the next video. Thanks a lot. Please like, share, and subscribe. Thanks for watching. Thanks a lot.